So let us understand what is a prime number. Okay, what what the theory says: any number that has only two factors, any whole number that has only two factors, which is any number if it is divisible by 1 or if it is divisible by itself is called as a prime number, right? So let us assume that I have set of numbers 1 2 3 4 5 6 7 8 9 10, right? If you check each and every individual number, so you can divisible you check one, you can divisible one perfectly divisible, one can be perfectly divisible by 1 itself. The remainder is going to be 0, right? So one is not a prime number and one is not a composite number. So for example, if you take one, mathematically you cannot say one is a prime number. At the same time, one is not a composite number, right? One is just a number which is neither prime nor composite, right? You want to put this in theory. One is neither for one, right? One is either a prime number or a composite number. And again, prime number is a number it has two factors, can be divisible by itself or can be divisible by itself and can divisible by 1. So this is the definition of prime number. If you take 1 as an example, here it clearly says 1 is not a prime number, right? So ignore 1. You consider 2. 2 can be perfectly divisible by 2 itself. It can be perfectly divisible by 1. Right? You cannot perfectly divide it with any other number apart from 1 and 2. Right? So 2 is a prime number. Right? If you take 3, again 3, if you take 3, 3 is perfectly divided by what? 3, and 3 is perfectly divided by 1. You cannot divide 3 with any other number apart from this 2. Right? So in this case 3 is also a prime number. Right? Let us take 4. If you take 4, 4 is perfectly divisible by 1, it is perfectly divisible by the number itself. Apart from that, 4 is also divisible by what? 2. Perfectly divisible. So it has 3 factors. Factor number 1, factor number 2, factor number 3. So 4 is not a prime number. Right? To take 5, again 5 can be divided by 2 numbers. One is by the number itself and second one is by 1. 6 has 3 factors and second 7 has 2 factors. 8 has more than 2 factors. 9 has more than 2 factors. 10 has more than. From 1 to 10 we are able to find there are 4 prime numbers. Right? The question is, write a Java program to find if a given number n is a prime number or not. Let us say that they have given a number like 9. I want to write a program to check the 9 is given number 9 is a prime number or not. Right? So first of all, how do I approach this problem? Right? So I have a 9. I need to find if the 9 is perfectly divisible by, if the 9 has only 2 factors, It is a prime number. It has more than two factors. It has more than two factors. It is not a prime number, right? So I need to write a program like if it gives me two factors, then it is going to be prime. If not, it is going to be, it is not going to be prime number. So how do I write this? How do I write this problem? So since I have assumed this as a given number, right? So before proceeding with the problem, we have to set a boundary. Why we have to set a boundary? We have to make sure that the numbers that are lesser than 9. So now if you are assuming you want to find a prime number for this particular number 9, you have to make sure that the number that is lesser than 9. Right? So what are the numbers that is lesser than 9? It can be whole numbers. If we talk about whole numbers, it can be 1, 2, 3, 4, 5, 6, 7, 8. These are the numbers that are lesser than 9. What are the numbers that are greater than 9? 10, 11, something. Right? These are the numbers that are greater than 9. So if I want to find a prime number for a specific target number, I need to ensure that this prime number has two factors. So I need to do check for each and every number. First check is going to be 9 divided by 1. So that is the first number. Right? 9 divided by 1 is not, it is not equal to 0. Right? And second check is 9 divided by 2. 9 divided by 2, again it is not going to be 0. Right? Third check is 9 divided by 3. If you do 9 divided by 3, it is going to be 0. Right? Because 3 ones, 3 threes. So the remainder is going to be 0 always. Perfect division. Right? So we got one factor. Again check 9 divided by 4. Right? So 9 divided by 4 in the sense, again it is not equal to 0. 9 by 5 not equal to 0. Right? 9 by 6 not equal to 0. 9 by 7 is not equal to 0. 9 by 8 is also not equal to 0. And 9 by 9 is equal to 0. So this is one factor and this is one factor. I'm sorry, 9 divided by 1 is equal to 0. So 9 has 3 factors. Right? So if 9 has 3 factors, it means 9 is not a prime number. So I have to start a loop from 1 and loop should end till 9. Right? So in this case, what I will do, I will write a for loop. Because whenever you are talking about a loop, whenever you want to execute a sequence of numbers. So here the sequence of numbers is nothing but, my question is I want to check the prime number of this is the number, this is a given number. I need to make sure that this number is getting divided by each and every number so that I can able to find the factors. So again, if you are starting this number from 1, you have to end the loop till it runs till 9, number 9. So I need to use a for loop. Right? For loop, what I will do, I will initialize the starting boundary integer like I equal to 0. The loop, I equal to 1. The loop should start from 1. I is lesser than or equal to 9. I plus plus. Right? So again, inside I need to do a check condition. If check. What I will check? If given number is 9, 9 divided by I equal to 0. Right? To count plus plus. So this again, this count is going to be a variable. What? We will initialize the count with the default value like count equal to 0. If the count value, is the count value is giving 2, then the number is prime number, right? If the count value is a number that is not 2, then number is not a prime number. Right? Because prime number can have only 2 factors. This if condition will execute only if the given number is perfectly divisible by the numbers that is sequentially getting executed from 1 to 9, 1 to 8, 1 to 9. Right? If it is exactly giving, if the if condition is exactly getting executed for the 2 times, the count is going to be 2. If the count value is 2, then it is a prime number. If the count value is more than 2, like 3 or 4 something, it is not a prime number. Right? Just type yes in the chat box if you have understood the logic. We will think about the program later. Just type yes in the chat box. Okay. So this is one of the ways to write a code for the prime numbers. But there is another way. So another way is that again same number I am going to take. So there is no confusion here. So here I am going to eliminate the little confusion. So same number pattern 1, 2, 3, 4, 5, 6, 7, 8, 9. And we were asked to check if the given number is a prime number or not. Let us say that I want to check if the number 9 is prime number or not. Right? I want to start a boundary. So we already know if first number, if the number is getting divisible by 1 or if the number is getting divisible by itself. Right? This is one factor and this is one factor. So we have 2 factors. We already know these conditions. Because this 2 factor, if the number has only these 2 factors, it is going to be a prime number. Right? If this number has any factor apart from this 2, right, it will be in this location only, right? For example, if you are taking number, for example, again, let me draw it once again. 3, 4, 5, 6, 7, 8, 9, 10. I am asked to find if the number 7 is a prime number or not. Right? If you want to find the number 7 is a prime number, I already know this number. I want to check the factors from the 1. I need to continue. Loop should be continued from the 1. Right? I already know this 7 is perfectly divisible by 1. I know this. And again 7 is perfectly divisible by 7 itself. Right? So 7 will be like 7 by 1. This is one factor. And this is another factor, 7 by 7. I already know these 2 factors, right? But I need to make sure if there is any other factor apart from these 2. It means I need to check if at least one factor is coming out from these numbers, then I can conclude that the number is not a prime number. Right? So if I want to take one more example, let us say that I want to find if the number 5 is a prime number or not. Or let us say if I want to find if number 6 is prime number or not. Right? I want to make sure that if the number 6 is prime number or not, first I need to find the factor. I already know that 6, if the 6 is divided by 1, if the remainder is 0, so this is going to be one factor, and 6 divided by 6, this is going to be another factor. 2 factors I already got. I already know that. If I find any other factor in this boundary, right? If I find at least one factor in this boundary, it means the number is not a prime number. So for the particular number 6, for 6, we have 2 factors. You can perfectly divide 6 by 2, right? This is one factor. And you can perfectly divide by 6 by 3. This is 2 factor. Right? So I have 4 factors for this. So this is 1, this is 1, and this is 1, this is 1. What I'm trying to say is just start the boundary by skipping one, and the skipping and by also skipping the given number itself, right? If I am asked to find if the number 11 is a prime number or not, we already know if you want to find number is not, if you want to check if the number is 11, number 11 is a prime number or not, I need to start the loop from 1 to till 11, right? What I'm trying to say is don't start from 1 and don't include 11, right? Start from 2 to 10, right? If the for loop is getting started from number 2 to number 10, if I get at least one factor, right? If the given number percentage of what I equal to 0, if I get at least one factor, right, I can conclude that the number is not a prime number, not prime. If the if condition is not at all getting executed, means the if condition count is going to be 0. If the if condition is not at all getting executed, then I can say the number is number 11 is a prime number, right? So let me take a new page. Now I got a question. What is my question? Please find if 7 is prime number or not. So how I can write this logic? Write it in a simple way. I can directly write a, you know that class A something is something common, public static void main. So the given number is 7. So integer, I am declaring a variable as integer num equal to 7. So directly I am writing a for loop. For integer I equal to, I am starting the I value from 2. Why I am starting it from 2? Because I already know that 7 divisible by 1 is 0. I already know that, I don't want to include it here. Second is I is lesser than what? Lesser than 7. It means 7 is not included, right? I plus plus. Right? From here, what I am to do? I am using a if condition to check. So instead of 7, I can just write it as number. Right? What I am checking? Check if number divided by number modular of I, because we want to find the remainder. Double equal to 0. Right? So what I am writing? System dot number is not a prime number. This for loop. and I am using the break statement. I will tell you why I have used the break statement. We execute this program. Here system dot out dot where is program? Let's try this program. This is a program. We already know as soon as we execute this program, a main thread will be created. This main thread will get access to the main method. So these are the things that we need to consider whenever we are writing a program. So the first instruction is going to be this one, right? Number equal to 7. Integer number equal to 7. So in the memory, there will be a block. This block is going to hold the value 7. And it is of num type. Okay. So here I am running a for loop. I am using integer I equal to 2. I is lesser than num I plus plus. So I can just simplify this statement, right? So what I am trying to consider here, I am setting up a boundary. The boundary starts from the boundary is going to start from 2, 3, 4, 5, 6. That's it, because 7 will not be included. Because if you say I is lesser than num is nothing but 7, right? When 7 is lesser than 7, this is false. So the statement is going to get removed. The boundary will be limited to 6. Right? Boundary has been set from 2 to 6. Right? The first iteration, we already know that this number 7 has two factors. One is the number 1 itself, and the second one is the number 7 itself. So that's why I'm not including this. If the number 7 has any, gets any one factor within this boundary, right? Then it is not going to be a prime number. If there is no factor that is existed in this boundary, then it is going to be a prime number. As simple as that. The first number is 2, right? For our boundary setup, initial condition is 2. It will check if 2%, number is nothing but what? 7% of 2 equal to 0. That is going to be false. So first condition, 7 divided by 2, it false. So this if condition, if block will not get executed. Second, 7 by 3 also false. Third, 7 by 4 is also false. Fourth, what? 7 by 5 is also false. 7 by 6 is also false. Right? So this if condition, this if loop will never get executed. Right? If the block is not at all getting executed, then the control comes to what? The control comes to this line. What this line says? Number is prime. Right? Hope you are able to understand. Right? This is one case. This is case. Let us consider another case. Case 2. Case 2, instead of 7, what? Instead of 7, let's remove this 7, okay? Instead of 7, let us take, check if the number 8 is prime or not. Right? So if you want to check number 8 as prime, the boundary, so this line, getting this line here, the boundary will start from 2, 3, 4, 6, 8 will not be included, right? Because we already know number 1 is one factor and number 8 is another factor. We already got to know 2 factors. We do not want to include that. Okay? So by default it has 2 factors, and our job is to find if it has any other factors apart from this 2. Okay? So take this line. So here first condition, number percentage of I equal to 0. Right? Here the number is 8. First factor is 8% of 2. So 8% of 2 is what? 0. 8 divided by 2, let's say like this. 8% of 2 is going to give me the remainder of 0. Okay? It means this if loop will be executed. This statement will be true. So this statement is going to be true. Right? If this statement is getting true, then this statement will be executed. Number is not a prime number. Not a prime number. Right? I am using the break condition, a break statement, branching statement. Right? Because I already know if the number 8 has a factor more than 2. So this is 1, this is 2. If you find any other factor after 2, right? If you find at least one factor after 2, break the loop. We do not have to check all the conditions because it will not make any sense, because prime number is already defined that prime number can have only 2 factors, right? But 8 for the first time, if it encounters another factor apart from 2, so for the first time it is encountering the third factor. Right? The factor, if it has more than 2 factors itself, it is going to be a prime number. So I do not have to check all the things over and over again, right? That's why I'm breaking the loop. I'm breaking the loop. If I use break, it is going to come out of the for loop. It's going to come out of the for loop. So again, what happens if it is coming out of the for loop? This will also execute this statement, but I do not want to execute this line after coming out of. So what I will do, instead of break, I will use return. Right? Return means if this if the if condition satisfied, it will get terminated from the method itself. Right? Just type S in the chat box if you understood this logic. We will write one program, real-time program, so that we will get some error. Just type S in the chat box. Hello. Hello. Okay. So let us write a new program on this. Same program I'm writing. So instead of let it be as hello world, okay? So what I am trying to do? So integer num equal to, let us take number. We'll check number 7. For integer I equal to 0, I is lesser than, not I equal to 0. I should be starting from 2, because we already know that 1 is going to be the factor of the given number. 1 is always a factor of any number. So we do not have to include that, and we do not have to include the number itself. So the boundary condition should be between 2 and the number minus 1. I can write in this way, or I can say I lesser than or equal to number minus 1. Both are same. So 7 should not get included. 7 should not get executed. So I can write in this way, or I can write in this way. Either ways I can write I plus plus. Right? So here I am using if condition. If but percentage I double equal to 0. If this if condition gets executed at least once, system dot out dot println the number is, I can simply say the given number is not prime. The number is not a prime number. As soon as this statement gets executed, I do not have to check for other factors. So I can just say return. Return means the program will be terminated. The loop will come out of this method. It means the program will be terminated after printing this. Right? If the if condition is not at all getting executed, right? If the if condition is not at all getting executed, then I have to print some dot the given number is a prime. So whenever the control goes inside, we can say that the number is not a prime number. Whenever the control is not going to this condition, we can conclude that the number is a prime number. So let's trace that. So 7, run this. The given number is a prime number. Because 7 is a prime number, we do not have any, this if condition will never execute for the 7 because there are no factors between 2 and 6. Okay? To divide 7, if 7 by these numbers 2, 3, 4, 5, 6, this is every number is going to give what? It is going to give false. So if you 7 by 2 is again false, 7 by 3 is going to be false, right? 7 by 4 is going to be false, 7 by 5 is going to be false, 7 by 6 is going to be false. Right? This if condition will never get executed. Right? So the control comes here directly. Right? Let us assume that, let us take the number 10 is a prime number or not. Let us take a small number, number 4 is a prime number or not. If I am giving the number as 4, the for loop will start from 2 and this 4 will not get, for loop starts from 2 and ends at 3. And again here 4 divided by 2, comma 4 divided by, the first condition is 4 divided by 2, right? 4 divided by 2 in the sense modular operation. I will be getting 4 divided by 4 percentage of 2. It is going to be 0 always. The first time the condition is going to be true. If the if condition is going to be true, obviously the control will go inside this loop. Then what will be when the given number is not a prime number. So if I execute this if statement only once, I don't need to check the other conditions because as per the prime numbers, any number is a prime number if it has only two factors. Right? If it has more than 2 factors, it is not a prime number, right? I have found already the third factor here. So I do not want to check the other factors because if it has more than 2 factors, it is it is not a prime number. So I am just terminating this return. Return means it will come out of the method directly. This is the method. The control will terminate this method. So it is not going to check execute this. As soon as it encounters return, it will be coming out of the. That's why the given number 4 is what? 4 is not a prime number. Right? What if I give 1? 1 is also not, because 1, if you give 1, this for loop will not get executed. Right? So 1 is actually, it is not a prime number, at the same time it is not a composite number. For 1, what I will write, if equal to 1, system.out.println, the given number is neither a prime number nor a composite number. Right? And after executing this, just return. If I am giving the input as 1, just it will execute this if block. The program will be terminated. This is another test case. The given number is neither a prime number nor a composite. Hope this program makes sense. But if you ask me, this is a good solution or not, definitely it is not a good solution because the time complexity is more. I will teach you about the time complexity in the tomorrow's class. This is how we approach a program. We were asked to find if a given number is prime number or not. Just type as in the chat box if you have understood till now.